everybody. Thanks for coming to another SensiLab forum. It's a pleasure to welcome Jeremy Kraybill, who's we met at the Creative AI meetup last year.
Yep.
Yeah, and he's been working on a fascinating project to do with artificial intelligence and art making, and he's entered in quite a very famous competition, which has what's the prize worth? The first prize.
First prize is $40,000.
$40,000 for basically AI that can create art. I'm sure he's going to tell us more about it. But please join me in welcoming Jeremy. Thank you.
Hey everyone. Thanks for having me. My name's Jeremy Kraybill, and I'm going to talk for about 20-30 minutes about the project and about sort of robot and AI art, and then we'll open it up to questions. So I'll first talk about the robot art competition and sort of the process that I went through, and a little bit of background about artificial intelligence for image creation, and then a little discussion about, is this art? What are we talking about here? Something I hadn't really thought about much before this. So I'm not an academic, I'm not a researcher, I'm not an artist, I'm not a AI or robot guy. This is just a spare time project for me. I'm a computer programmer, software developer by trade. I also serve as the chief entrepreneur in residence at the Melbourne Accelerator program, which is a startup accelerator over there. And that was sort of how I got interested in artificial intelligence. I was starting to see startups that were talking about artificial intelligence. I've got a very limited background in AI, and I wanted a project that allowed me to sort of actually learn some of the underlying tech, as well as maybe fulfill some hobby stuff. So that's how I got into it. And about 3 years ago, I started playing with image generation. It wasn't AI at the time, it was just sort of a hobby. And about a year into that, I found out about the robot art competition. So this is a competition that is in its third year this year. It's one person, Andrew Conru, put up $500,000 of his own money over 5 years to promote not necessarily AI, but robotic art. So using a physical robot to produce physical paintings. So it started in 2016. It sort of started as a mostly university competition, but over the last couple of years, it's really broadened into a lot of enthusiasts like me, professional artists, and we've seen a growing amount of AI being used in the competition. There's two categories, which is original artwork, created probably by an AI. Some of it's sort of generative, where you've got robots going on canvases, et cetera. And then reinterpreted, which is usually taking a photograph and rendering it as a painting. Requirement for the competition is that there must be a physical robot arm using a painter's brush. It's a little bit vague about the definition. And using any form of paint with a maximum of 8 pre-mixed colors. I used 5, and this is the painting that I submitted. As I mentioned, AI isn't a requirement, and then you submit one or more paintings and you're judged on your body of work. This was the first year that I submitted. I started working on this project about a year ago. I finished it like 2 days before the deadline, maybe 1 day, and I submitted just a single painting, and I ended up coming 6th, and was the only person who had only submitted one piece that got recognized. There were 3 people from Australia that submitted. All 3 of us got recognized, 6th, 8th, and UTS got honorable mention. So when I got interested in the competition, these were what had been submitted year 1. And when I looked at them, I'm like, well, I know I can do better than that. And I was really interested in sort of taking my software ability and combining it with what I had learned about art. I started learning painting about 7 years ago. I'm not a very good painter, but I was really interested in, can I sort of meld these things together and produce some paintings that I would like on my wall. Last year, these 4 paintings, looks like we're having, is this maybe an issue here?
Sorry, it's not you.
Okay, cool, I'll just keep going. These were some of the winning entries last year, and those are the winning entries this year. It's an interesting competition. It doesn't have much of a strong point of view as to what should be submitted. It's really about what can you achieve technically with a robotic arm on the page. So this was the piece that I submitted. That's the name of it. That's a generated name by the software that I created to produce the painting. So I basically took a set of AI programs and used them to generate a source image from scratch. So I'll talk about the AI training in a minute. And gave it a set of sort of aesthetic goals that I had for the project. Eventually that translated into a series of robotic instructions that were painted with an ABB robot arm, physically mixing paint. We'll see a short video of that. The whole project, I've spent several hundred hours of coding and training. That's really to set the foundation for the ability to produce this stuff. The actual painting process was about 3 hours. And when I sat down, I really have not thought about going back into the lab since I finished this, because I was kind of burnt out by the end of it. But for my next projects, I think each piece will be about 20 hours of my own work. So the foundation is there, but it won't be as much work going forward. I'm pretty happy with what came out of it. This project for me was less a effort to produce a work of art and more a technical proof of concept to see what I could do. I'm going to take a detour right now and talk about artificial intelligence and what we're talking about here in terms of image production and generating something like this. So when most people talk about AI, especially in the media, you probably see images like this, you probably see images like this. But when we're talking about especially neural networks that deal with images, so that's image recognition and image generation, what we're really talking about is this. And how many of you deal with AI, like from a programmer's perspective? A few. So this might be a little bit of repeated basics to those folks. But for the rest of you, what we're talking about, when we're talking about an image processing neural network, and you peer under the covers, they are excruciatingly simple. There's just a lot of it. And so when I say very simple, what I mean is, this is a diagram of a very simple neural network. You've got input nodes, and each of these, think of the contents of a node as a number between 0 and 1. In between, you have what are known as hidden layers. So these are the processing layers of the network. In modern neural networks, there might be many, many, many of these, dozens, hundreds. But again, each one of these nodes just has typically a number, typically between 0 and 1. And they generate some output. In this case, the output is a single number, probably between 0 and 1. And the arrows that you see here are very simple mathematical operations, typically addition and multiplication. Maybe some offsets, so you may take a number like 0.5, you might multiply it by negative 0.025, and then you pass it through a very simple transform. Now, in an image processing neural network, each one of these nodes is typically going to be 1/3 of a pixel. So there's going to be one value for the red value of a pixel, one for green, and one for blue. So if you've got a 10 by 10 image, this will be 300 inputs. You may have a number of hidden layers. And then the output layer, if you're trying to take an image and produce another image, a very common type of activity, will be another 300 outputs. And those will be compiled back into an image. You start off with all these numbers being random, essentially, so all of these transformations in the middle just being randomly initialized. There's different ways to initialize them. And you give the network a whole set of inputs and a whole set of what are the correct outputs that you would like to see. So in image generation, maybe something like colorization. These would be black and white images. These would be the color version of them. In something like image classification, these would, again, just be the raw images from something like the ImageNet database. Each one of these output nodes would probably be a class. So there'd be one node for car, one for dog, or each breed of dog. And you tell the network, I want you to produce a 1 here when this is a dog and a 1 here when this is a car. And so give it a shot with this random thing, and it's probably going to say 0.5 for everything. And then you just keep going. And every time you get outputs that are wrong, the ways in which they're wrong allow the network, depending on how it's training, to modify these very basic mathematical equations. And when you have enough of these small, pretty almost mindless operations that are happening with a network, when you have a deep enough layer and you do a fairly small number of intelligent things with how you train it, how you set up your data, you can get pretty astonishing results. When I talk about those operations at those nodes, this is the number one operation used in almost all of the state-of-the-art image processing today. If the input is less than 0, it returns a 0. If it's greater than 0, it returns the input. That's how basic these operations are that we're talking about. But when you combine enough of them together, you get really interesting results. And when I say combine enough of them together, this is a diagram of kind of a typical basic image processing network. Each one of these may be like 64 layers of the size of the input, then another 64, then maybe 128. The sample size gets smaller, but eventually you get really interesting outputs. And the thing that I always think of is this quote when we talk about humanity. So hydrogen is a light, odorless gas, which given enough time, turns into people. That's how we got here. But with neural networks, what we're really talking about is these ridiculously simple mathematical transformations, when you do enough of them and you do them in the right order and you train it over enough time, are starting to give us results that in some cases are better than people in terms of what they can accomplish. So the ImageNet challenge, this is image classification. It gives you an image like this. The AI must return preferably not the word cherry, maybe the word Dalmatian. 2015 was the first year in which AI neural networks of this sort exceeded human accomplishment in the ImageNet challenge. And now they're pretty significantly above that. For instance, these networks are much better than even expert humans at identifying dog breeds, and a whole other class of problem that humans simply are no longer superior in. When you look under the covers, different layers of the neural network are actually evolved to start representing different things, and that's what we're seeing here. They're exceedingly good at activities like automated colorization. Anything that has a set of inputs that are mapped directly to outputs can be trained very well. So in this case, the network was trained on kitten pictures that have been turned into line drawings, but then it was asked to go the other way. So now you get a network that you give it a line drawing, and it gives you a kitten. Any activity like that, these networks are very good at. Things like taking street scene pictures that have been sort of colorized into different regions of road, turning satellite images into maps, turning day photos into night photos. That's very similar to the kitty activity, black and white, and then creation of building facades. All these are done through this type of network. There's another thing you can do, which is you can take one network that takes image-sized inputs and outputs and hook that up to another network that takes image-sized inputs and outputs fake or real. And you feed it a set of real images and the set of fake images that are coming from the generator, and you're basically trying to train a generative network to fool a discriminatory network into thinking that these artificial images are the real images. And so in the case of this painting, what I did was I took a not very large set by AI standard of paintings, and those were the real images, so they were representative of the types of images that I wanted to produce. Trained what's known as a generative adversarial network like this. It took close to a week, I think, and then it started producing things that looked like paintings. These are images that are created by one of these GANs. These are not real people. This is a GAN image generator trained on celebrity faces. None of these people have ever walked the earth. And for the most part, sometimes these produce things that look like the source set, but for the most part, they produce images that really don't look like the source at all. They can do other interesting things. So there's now some really cool GANs that you can feed it a sentence. This small bird has a white breast, light gray head, and black wings and tail, and these are generated from the input, not actual photos generated by it. So for my project, I took about 15,000 paintings that I hand labeled over about a 3-4 month period, and I used that for a different type of discriminator. I wanted a set of networks that can evaluate generally any of the image output that I have. Do I like it? Is it a landscape? Is it a male or female painting? Is it a portrait, etc.? Then I took about 1,000 hand-selected paintings. Most of them they were all sort of in this vein. So think like 19th century, turn of the century expressionist portraits, which is what I picked for this project, and fed them through the GAN. The GAN produces hundreds of thousands of images as it trains, and one of the things that I wanted to do was make sure that I didn't have to look at all of them. So with those 15,000 paintings, I produced a set of networks that have been trained to sort of work on my behalf and at least filter the output. So they could tell me, like, does it think that I will like what it's produced? Is this something that is in the vein of the paintings that I've told it are what I'm looking for? I got to the point where it was pretty good. It was, depending on the types of paintings I was evaluating, it was like if I did a blind test with my own results and with what the network said, network was getting about 80 to 90% correct. And so, these are examples of paintings that network said thumbs up from JK. These were ones where it said thumbs down, and those are pretty consistent with what I was looking for from this project. When you look at the generation, so generation starts with random noise, and as it gets data from the discriminator, it starts producing images that these start to look like faces. This is like less than an hour of training. As it goes, it learns, and the images start looking a little bit more like painted faces, a little bit more, and then eventually started getting some pretty interesting results. And this is one of the sets of outputs that resulted in the painting below. So this was the image that was selected for creating that painting. That was the source. What I did from there was I took the source image, which was it's a tiny image. It's 64 by 64 pixels. That was the GAN that I was working with, is generating just 64 by 64 pixel images. And then I've got a production pipeline that basically blows that image up and translates it to robotic brush strokes. That part of the project took by far most of the work, so I probably spent, it was a really long time. Over the last 2 to 3 years, most of the time on this project has been spent on the image to physical robot instruction code. And that's, that's also because that's really the only code I had to produce from scratch. All the neural network libraries that you can deal with today are really easy to use. You can create some very, very complex, deep, state-of-the-art networks with like 100 to 200 lines of code these days. This stuff was just a ton of trial and error. So this is the execution plan of what different, you can sort of think of it as AI. It wasn't using a neural network, but it's using AI techniques to translate an image like that into a color palette that can be mixed with the paints available, and then created a brush execution plan. It was 4,000 strokes, which I selected because it was about that point the paper starts kind of falling apart. So this is actually paper that's stretched over stretcher boards. So we created the whole execution plan, and then I went into I used the Fab Lab at Melbourne Uni and produced the painting over. It ended up being one night. I went in initially for 2 nights and screwed up the first attempt really, really badly, to the point I thought I wouldn't submit this year. So the colors were all wrong, and then and I was still going to submit it, and then at the last minute there was a 1-line bug in the code that caused a brown stroke to be painted right across the middle of the painting. And it was like, I thought it was my last night in the lab, and I went home and I couldn't sleep, and I was like, I'm not going to submit it. This is embarrassing. And then I got one more night in the lab and finished it. I think I can play this here. So just real quick, we don't need sound on. There is sound for this, but I don't want it on. So this is what it looked like in action. This is real time. So this is the starting of the paint. And so I've got, this was like sort of a cream color, and then there's 4 other colors, and as it goes along, it's mixing, it's cleaning the brush, and then it goes and mixes some more, and then it paints more on the page. If you're interested in like more technical details about the robot side of stuff, there's an article in Hacker Noon with the same title as this, I Can't Paint But Beat My Robot. It's got lots more videos and narration, etc. to it. And then here you can see like that's all the color changes. It's stopped from mixing up there to mixing in these bottom palettes, and it's almost done. I stopped it like 3 times to fix some bugs and change the color mix mostly, which was done at the last minute, but I was pretty pleased with how it came out. I can't see the cursor. There we go. All right, so I guess the next question is this art? And it's a question I sort of had been dodging the question of like, what is art my whole life, because it just wasn't that interesting to me. It seemed like something that philosophers and art historians are better discussing. But I actually started thinking about it a lot for this project, and like, is this art? Like, people were asking me all the time, like, is this art? I'd be like, a standard response was, well, you know, you first have to define art. Well, maybe we can do that. So this is a dictionary definition of art. I'm sure it's regarded as incomplete by a lot of people. But it captures something that I think is pretty important. So it's saying art is the expression or application of human creative skill and imagination, typically in a visual form, such as painting or sculpture, producing works to be appreciated for their beauty or emotional power. This is a dictionary definition. It doesn't define what everyone thinks art is. But what I think art is human expression. It's a capturing of human expression. And so for a work like this, to the extent that this captured a human expression of something, I think, yes, that does make it art. And I think if it doesn't capture a human expression, it's not art. And so for me, like, this isn't art, because what I was seeking to do in this project was not express something on the canvas other than the ability to produce a work like this. This was a technical proof of concept for myself. What it has proven to me is that I can use a format like this to produce art, and I do consider that to be art, and I think that many of these works will. But I also think you've got a number of people who are working on AI creativity, where the point of the creative exercise is to completely take the human out of the equation, to make creative artificial intelligence. And I think that's a really interesting technical exercise. I think, at least at the moment, that doesn't meet the popular idea of art, because it doesn't involve a human expression. So, you know, when I'm asking myself, is this art? Well, is it an expression of human creativity, creative skill, or imagination? To me, you know, this wasn't for me. This was a personal technical proof of concept, but I feel very satisfied that it could be. And is it, or can it be appreciated for beauty, emotional power? Can it capture ideas that a person has? I think the answer is yes. And, you know, when you look at things that we currently regard as not art, so animal created things, nature created things, animals. This is a painting by a monkey. It just sold for $20,000, but it, you know, it was that purchase was laughed at by the art world. Over here you have art. This is a pile of sunflower seeds produced by Ai Weiwei. These are empty canvases in a magazine. No, sorry, in a gallery. This was someone dropped their glasses on the ground, and people started photographing it at the San Francisco Museum of Art, because they thought it was art. Because they thought a human had done this. It's just a pair of glasses on the ground, but it could mean something that someone wanted to say, and cave painting. So I think when you look at the left side, there's a lot more technical, impressive accomplishments in here than things that we definitely regard as art. They can be very difficult. They can take thousands, millions of years. They don't contain human ideas, and they're not made by a human. And so for me, you know, I think, talk about that. So I think what's interesting about the types of techniques that are available to people now in AI and what you can do with them, it's a new set of tools, but they're not that new. They're not that new in terms of what we're given as humans to make creative expressions. So they definitely open up new possibilities in sort of the types of technical expressiveness, the level of detail, the level of sophistication that they can have. But, you know, tools like the camera have been around for a couple hundred years, and before that, the camera obscura. Like, these were technical tools that opened the door for new types of technical expression. I'm very interested in sort of the idea of the transfer of will from myself to one of these networks. But that's not a new thing either. I mean, when you think about it, so the fact that I can say I want to produce a painting and let's sort of imagine it and maybe do some form of collaborative design between me and the AI, and then I can click a button and go to sleep, and a robot is painting that, but it's still my work. I would still consider that my work. That's not that new. I mean, woodblock prints, I think, are an example of something that's quite similar, where Hokusai engraves the wooden blocks, but may not even be involved in the actual printing process, is saying that he wants the printing process to occur. And then also they open up new possibilities in the transfer of taste. I mean, the interesting thing for me coming out of these discrimination networks that I created were they were working on my behalf. And they were pretty good at capturing what I would have done if I was in that situation. They can work in my absence. I can look at the results or not. The fact that I train them means that they really embody like my taste, my ideas. They're not. This isn't just is this a cat versus dog, but this is would Jeremy Kraybill give this a thumbs up, and it's pretty good at that. So for me, like the interesting thing that I really want to play with is the ability to transfer my will and my taste and delegate it and work with a network like this to make my own forms of expression that at the end of the day are just human expression. That's what makes them art. And that's sort of what I'm going to explore. There's also some interesting opportunities for collaborative design. So we can take different people's tastes or goals or other values that they feed into their own trained networks and combine them together and get results that are pretty interesting. I've been playing a lot with that. I think there's a lot of looking into the future happening right now, and the question of like, will there be robot artists that are as famous as Picasso, and will autonomous AI art become considered art? I mean, for the vast majority of the world today, it's not. But I think for us to get to the point where autonomous computer-created or artificial intelligence-created art is regarded as first-class art, just as the paintings that hang in the galleries, a few things have to happen. I think the art itself, it not only needs to be indistinguishable from human art, but if you were to design a Turing test around computer-generated art, it wouldn't be just hang this in a gallery, and if anyone thinks it looks suspicious, like that didn't pass the test. It needs to have an artist statement. It might need to be able to answer questions about that art. It might be able to need to tell a backstory or give it a title or an artist statement. I don't think that's going to be enough. I mean, I think that if you had that test today, you could probably have a pretty good shot of passing it. This doesn't mean it's art, because the AI that's producing it itself is still not indistinguishable from humans. I think we'll need to get very close to that point before we as a species actually regard this as like, this is art as much as any Picasso is art. And I think there's various reasons for that, but I really think that that's what we're talking about. If you're thinking about the stuff, is it going to be art? So for me today, I just think that's pretty far in the future, and it's not really where my area of interest is. My area of interest is using the tools at hand to enhance creative expression, especially my own in this case. That's it. Thanks.
So, thank you, Jeremy. Questions?
So you say this is a bit of a side project or a bit of fun on the side. So what's the next thing you're going to aim for then? So you've got this broader statement of what you're interested in, but do you have another competition you want to go for, like next year, or is there something quite tangible that you're aiming to produce over the next 12 months or so? Or?
Yeah. So the answer is yes. What I'm working on right now is multi-person collaborative digital art. So it's specifically looking at can I maybe plant the seeds of a painting that is ultimately created by an AI and then hand it off to a friend who can then evolve that in a certain way. And I'm getting kind of interesting results super early. I'm trying to commercialize this somehow because I'd like to spend more time on it. So I've asked ABB, the robotics manufacturer, to give me a robot, which would help a lot because the robot lab is only open 9 to 5. I have pitched a number of big companies on like doing robotic installations. This is just to fund the work, right? And And then I would like to do a full gallery show in the future, but to be honest, I need to get better access to robots before I think about that, because if I had a robot at home or like somewhere I could get access on Saturdays and Sundays especially, I could produce a lot more work, which I would love to do. Until that time comes, it's like getting out a few pieces a year is about the best I can hope for. But I'm going to get one somehow, and then a lot of possibilities open up. This is going to be exhibited at the Seattle Art Show in August, and unfortunately I can't go to that show. I think it'd be pretty interesting, because I'd love to see some of these works in person. I don't think the online pixelation does them justice.
Jeremy, that's fascinating talk, thanks. But I was just interested, you mentioned that about midway through your talk, there are some researchers who are looking at creative art, and they're interested to see if the AI could be autonomously creative, take the human out of the loop. Can you elaborate, what are some of their kind of goals and intentions there? Are they, in pursuing that goal, I guess, is it partly because there's this common refrain, especially about the new jobs market, that it's the creative jobs that'll be the most, because humans are creative and a lot of these other jobs are going to be automated. So if researchers are looking to make a truly creative AI, made one day, what are the motivations with that? Just because
you'll have to ask them. I mean,
yeah.
it's a very interesting question, and it's a big sort of, I guess it's a challenge. And when I first came across this stuff, that was my first thought. It was like, oh, this is great. I can like sort of program an AI doing things that I sort of want it to do, and then it can just produce stuff forever, and maybe it can evolve over time. But it's not where my interest is anymore. If you look at, the winner of Robot Art this year, Pindar, he's also known as Cloud Painter. He does a lot of talks on this. Like, he is kind of probably the only well-known robot artist guy, and he talks about this a lot. It's kind of his goal, is the creation of creative machines.
Does this kind of is general AI intelligence, instead of narrow intelligence? Is it
I think
kind of
that's
a step in that direction?
I don't think any of this is a step in that direction, to be honest. I mean,
Yeah.
I think what we're doing right now with these image processing networks, it can't lead to general intelligence, in my opinion. When you see what it's doing, you get some really interesting human-like results that you wouldn't expect to get from a bunch of very simple mathematical transformations, but I don't think that's where it's going. I don't know what, I think it's just an interesting idea.
Okay.
But I think it's not long in the future at all before a significant amount of our entertainment content is produced not autonomously, but near autonomously. Like human filters, human knobs, and sort of feed it some premise, and then it's going to create like Cars 29 or whatever. I think that's going to be happening. Get ready for it. I mean, it's already happening, right? But it's going to be like literally Cars 29.
So you said you sort of as a side project you're like a computer programmer who sort of started dabbling into this. So now that you've sort of gone through this process, are you more interested in like technical tweaking of the architectures and the networks that you play with, or are you using like super picture picks, and then you're more interested in what you can get out of them? Like, where does your interest lie?
Despite the fact that I have to wear a suit today, I'm a super nerd, and I absolutely love getting under the covers. So I'm actually right now playing with an alternative GAN architecture that I've created. I think it's got some potential. I have some theories. So I didn't really know this at the time. I don't have a background in computer science. I'm a self-taught programmer. I've been programming since I was 8 years old. I got given a client project 10 years ago that I knew almost nothing about neural networks at the time. But the way that the problem was presented, I was like, this seems like something that one of those neural network things I heard about in college could be used for. So I wrote one from scratch after reading the Wikipedia page about neural networks. And I did things in the programming that don't exist in the network architectures you see today. And most of them were really dumb ideas, but I think there was a couple ideas in there that are very underexplored. And so I'm playing with them. The problem is that it's just the amount of time and AWS credits you need to sort of mess with that stuff. The thing I like about it is you can sort of go to sleep and then wake up and get some results, but it's really time consuming. I'm never going to publish a paper. I don't even know if I'm going to get like good results. I'm just really hoping at this point for like different in a good way, and I'm already getting different in a good way. So yeah, I'm using mostly Keras and TensorFlow if you're interested in like the underlying architecture stuff.
I just had a question about that black and white picture you showed earlier on. It's a famous picture from the Depression.
Sure.
So it colorizes the black and white image, but does it? You're saying it has a really good guess whether the grey sweater or jumper that the person's wearing is actually blue from the or is it kind
really
of
good question. No, it doesn't.
range? Yeah.
And it does have a good guess, but the good guess is not generally
Is that
based on
informed?
when you talk about like what it is remarkably like. There's a bunch of colorization algorithms out there,
Yeah.
and what they are remarkably good at is colorization of things that you can sort of recognize that this should be blue, like Civil War uniforms. Like
Yeah,
it's going to be very good at colorizing those.
Okay. So there's been some human input giving it some kind of parameters that say, these are historical likelihoods of that period. If it's a civil
No,
war,
no, no.
it's
They're trained
It's
on
trained on
mammoth databases. So what you do to train a colorization algorithm, you take say 10
Oh,
million
using paintings
photographs.
as well.
You could do anything, but you generally want your training set to be very similar to your target set, whatever
Yeah,
you're going to be using.
yeah.
But you give it you take 10 million photographs off of wherever you want, Google or the image database that are color,
Yeah.
and then you convert them to black and white, and then you train them on the black and white as the input. So it will learn naturally, and most of these are also built on pre-trained networks to some extent that already are pretty good at object detection,
Yeah.
but then they learn the colorization from there. So it will sort of already know off the bat, like, where are the shoes in this picture, and then it takes all of those inputs and will use them to generate colors. If its data set had 100% of people wearing shirts that are white, it's always going to colorize to white. If it's got a mix, it may be able to take some contextual information. And if the objects can be distinguished and matched to a color, it's going to be very good at that. But knowing the color of like a t-shirt that has nothing else, it will be able to get the right shade, but it could be blue versus green. It's pretty good at it though. You
Yeah.
can look at some of the stuff online.
Yeah, I'm just really interested in some of those early black and white photos, probably the beginning of photography, when you probably got different chemical dyes and stuff that are in use
Sure.
today, and what colours those would be. You can only really look at historical paintings to get an idea as a person, but
Yeah.
how that could be trained is really interesting.
Yeah, and the most effective way to train that would be to get a whole bunch of them and hand colorize them based on what you know. That's a
Yeah.
ton of work. Like
Yeah.
the amount of data required to train these is like insane. To get those 15,000 labeled paintings, that was me 100% of my television time for like 4 months. There just isn't data out there that was the type of data that I wanted. And that should always be your first resort, because the amount of data that you need to get results, even 15,000, is kind of weak.
I'm going to ask a question about sort of switching the conversation to ethics and authenticity. So, all of these networks are trained on pre-existing data sources. It's a big controversy at the moment in AI in general is the bias of the data sets
Sure.
that are used. So, if you train the painting that you made on thousands or hundreds of thousands of images made by other human artists, most of what the neural net learns comes from the learning that those people, so they're the primary source. So how do you feel about attribution when you've trained on existing artworks?
Yeah, I have thought a bit about this, and actually, GANs have a problem with forgery. So, GANs, most of the current GAN architectures, left to their own devices, will end up producing works that look very similar to some of the inputs. Some of the outputs will look very similar to some of the inputs, and it happened with me. And I think you really can't take an approach any different than you would take with a human painter when you look at the product. So if I produce a product that is a violation of copyright, there are laws around that, and what I attribute, I feel that it's sort of the same concepts apply. There really isn't anything different in what we're doing here than, and I think it's the way that it should be legally viewed, is we regulate this the same way we regulate thought processes, which is you just have to look at the end product and maybe ask some questions about it. For the stuff that, what I produced was, I actually created another AI that looked at the output of the GAN and rejected anything that was anywhere close to the inputs. So for me, it's,
So, but my point is not really so much about the exact output, it's the source of the creativity is coming from somebody else. It's coming from humans, it's not coming from a machine, and yet the humans don't get any credit for that. So, you know, there was a similar situation when sampling in music first arose. People could sample, it was obviously more literal, but they could sample things, and there were mashups of things. And eventually sampling became an art form in its own right, but there was a big ethical and legal battle about, well, if I just record someone else's music and play it back, but it's not, you know, I'm sampling bits and pieces of different things, and there is some creative process involved in it. It's now recognised as a whole genre, and it's creativity in its own right. Whereas with this, it seems that the major human input in making it is just simply sampling other people's work. There's no human creativity in the output.
I think that's one way to view it, but even when you look at it like that, the learning output of the network is a I think it should be viewed as a similar process to someone learned to paint by only looking at Picasso paintings. If what they're producing at the end of the day isn't a copy of Guernica, I don't see the issue there personally. I think that there's some very interesting legal stuff happening in the US around, like, are you allowed to use my protected copyright material as an input into a training algorithm, even if you can provably say that the output of this training algorithm doesn't actually contain your encoded work in it.
You can't copyright style. You can copyright an image,
Sure.
but you can't copyright a style. But just simply reproducing someone's style is not considered to be very creative. Someone
Sure.
invented that style.
Sure.
So I guess that's the big unanswered question, is whether you can actually innovate in terms of new styles.
Yeah, I mean, I think actually, so the output of my similarity algorithm, the training image that was the most similar to this image, I included it in here, is the painting on the right. So I mean, I consider that to be pretty different. There's a few Modigliani portraits, I think, that have some similarity, but a lot of it, yeah. I mean, I had personal input into the palette creation and how the brushstrokes are created. So I don't know. There's definitely some gray area in there. And it's going to come up in film production, for sure. That's probably going to be the first place the battles are fought.
Yeah, definitely. Yeah. Any other questions?
That's perhaps more of an observation, just from the perspective of an artist, not a broad programmer. To me, the most interesting thing is the process rather than the output. And so, and I think for a lot of artists, that it kind of goes a bit towards the sampling as well. So until the thing gets recognised for its inherent attributes that can be used as a tool, for example, the output doesn't really know. The output is a kind of similar kind, but the actual process could be very interesting, and most likely where it starts to go wrong, you know, and go off the track, and that's where you get your human appreciation come back into it. This is where we start to ascribe a meaning that we hadn't actually put into the input set, if you like, or hadn't anticipated that degree of meaning to come out of it. And it's likely to be some little error in the program, that brown line you were so worried about. That was probably a really interesting thing from my perspective to keep in there. But because it didn't meet the criteria of what you expected, that it went off into a different territory. But I think as these things develop, like sampling's taken on its own qualities, you know, there are nuances. You can create new meaning out of existing elements, and that's where, you said already, that it's really just another tool. And to me, that's where I think we're very interested.
Yeah, I agree. I mean, there's so much. This field is changing so rapidly that it's actually right now. If you took like a few different approaches and pieces and tied them together the way that you want, you can get really interesting results. But by the time you finish that project, all of those pieces are kind of like old technology.
Yeah.
It's changed so quickly, which is one of the things I like about it as a software developer. It's a really interesting field to be in.
Great. Okay, if there are no more questions, let's thank Jeremy once again for a fascinating talk. Thank you. And our next forum talk, Lizzie, is going to be...
In July, so it'll be a bit of a break over.
Yep.
And then we'll pick up in July.
Great, so please come again in July for the next... Thanks for coming, everybody.